What is going on with humanoid robots in manufacturing and the warehouse? My guest today is Melanie Wise. She is Chief Production Officer with Agility Robotics. Melanie, hello.
Hey.
Thanks for being with me. I really appreciate it. Humanoid robots, interesting. It's always fun to talk about them. They're the stuff of science fiction, but in the world of manufacturing in the warehouse, are they happening?
Yeah. So today, they actually are happening. There are real-world deployments for humanoid robots. The company I work for happens to be one of them that's deploying robots right now. But there's a lot of players in the space working towards that goal as well. But yeah, you can go and see robots, humanoid robots, much like you can see AMRs in the warehouse today, deployed, working, solving problems, hitting an ROI that matters to customers.
Yeah. I mean, it's really cool
Yeah.
to see a humanoid robot. It's a lot of fun, but it makes me wonder, though, does it make sense to even try to design a robot based on a human body? Our bodies are not that efficient. We're bipedal creatures. We're not that stable.
Yeah.
Why are we designing robots based on our model?
Yeah. And I think there's a lot of grayness here because I think people call them humanoids, but it doesn't mean that they actually look like humanoids or even have, or humans, I should say, and have the same attributes as humans. Because I would say most humanoids today are somewhat superhuman in their capabilities. They can lift payloads at much longer reaches. Some of them have more degrees of freedom in their legs in different ways. Some of them have reverse knees, let's call it, or have actually bird-like leg architectures.
Interesting.
So those are some aspects of it. But when it gets down to like, are wheels better or are our legs better, it depends on what you're trying to solve. Because one of the advantages of having a dynamically stable form factor is when you lift something up that's very heavy, like a meter out, you can change your center of gravity.
Right.
But when you're statically stable, you don't have that ability. And a lot of times what you do is you just make the base of the robot bigger and bigger and bigger.
For solidity
Yeah.
purposes, yeah.
Yeah. And what that ends up happening is the aisle width in the facility gets bigger. And as we all know in manufacturing and logistics, no one wants to give you more square footage. Everyone needs to operationalize every inch in their facility
Right.
to make it productive.
Well, I mean, is a robot arm considered a humanoid robot, or by definition, are we actually talking about a machine that has arms and legs and the semblance of a head, and
Yeah.
stuff like that?
This is a great question because the technical definition of the thing that people call humanoids is a mobile manipulation robot. So the arm is, in standard terms or in technical terms, just an industrial robot arm. And so when you look at humanoids, that's like the layperson's term, you know? And so when you talk about the technical terms for the industry, you have mobile robots, which are just wheeled platforms a lot of the time, or actually legged robots. But when you add arms to it, it's just a mobile manipulation robot. So
I see.
it's mobile and it's manipulating. But most people, when they call something humanoid, it vaguely looks like a human.
Got it. Okay, again, though, I have to ask, like a robot hand.
Yeah.
Does it have to be 5 fingers? Can it be 6? Can it be 3? I mean, why 5? You know, is it always 5?
Yeah.
What's the deal?
I'm with you. I don't think that it makes a lot of sense for us to try and copy the human hand for lots of reasons. Because we use tools every day in our daily work. And it's a lot easier, even when you look at something like riveting. When humans are doing a lot of riveting, they actually have an auto riveter. So they don't grab a single rivet and put it in the gun and then do the riveting. They actually have a feeder that feeds it, and then they're just pulling the trigger and riveting. And you would put something like that on a robot if you were trying to do a whole bunch of riveting. And many of our customers have requirements for holding, you know, like, does it need to be, is the device ESD sensitive? If you build a generic hand, it may not meet those requirements for the things that the customer cares about. How you hold it, maybe it's a bearing and you can't touch the inner race of the bearing. Well, it's a lot easier to do that with something that's fixtured. And so the last 50 years of industrial robot arms, none of them have been deploying 5-fingered hands.
Oh, really?
They've been
In my imagination.
they've they've been focused on specialized end-effectors that achieve the right outcome for their customers.
Are they purpose-built, though? I mean, you're designing different robots, different hands, different things for specific tasks? I mean, that would seem like very impractical considering how many potential tasks there are in manufacturing the warehouse, but there's got to be different types of warehouse, different types of robots for the task to be assigned to that.
Yeah.
Right.
Yeah, so actually what you see in a lot of devices, like a CNC machine, is a tool changer.
Oh.
And now if you reframe the problem as my hands are different tools, then you just change your tool. And so I actually see the path for humanoids or any mobile manipulation robot is they have changeable hands. And they can have a mixture of more generic graspers that can grasp a wide variety of objects, or specialized graspers or end effectors when they're trying to grasp specialized objects.
Makes sense. What about issues of safety with regard to humanoid robots performing in environments where they're also...
Yeah, it's a huge issue. When you look at safety, specifically for dynamically stable mobile manipulators, so what it means to be dynamically stable is when the power is removed, you fall down. And there are some special issues that arise from being dynamically stable. A lot of our safety standards today are focused on statically stable robots. And so there are special things that we have to do with these robots to ensure that when they lose power, they end up in a safe state and don't hurt people. One of the biggest things that we're working on as an industry is something called safe human detection. So you've probably seen lots of demos where Facebook can identify a person in a picture, but when you talk about making it safe, it means that it has to do that 100% of the time, basically. Well, not 100% of the time, but 1e to the -6 times it can get it wrong. And so that kind of reliability is something that we're working on as an industry and developing the ability to detect people, because when you can walk out into the world and touch everything, you need to make sure that the thing you're not touching or the thing you're touching is not a human.
Yeah. Well, I mean, you see AMRs, autonomous mobile robots, zipping around warehouses all the time, and they have collision avoidance, and they know when a person's supposedly...
They don't know.
They don't?
No. They know there's an object there. They don't know
what the object is.
Yeah. They just know not to hit anything.
Yeah.
The rules for AMRs and mobile robots is don't hit anything, don't touch anything. But when you get into mobile manipulation, now you have to go pick up something like a box or a tote. And you need to make sure a human hand is not grabbing that tote at the same time.
Right.
And so you need to know that this is the edge of the tote and this is the human hand, and not to touch it.
But this is the technology as it currently exists? It is effective, or is there more work to be done?
There's a lot more work to be done. It's actually an entire new area of work that people are focusing on right now.
Interesting. Well, Melanie, thank you so much for helping us understand what's going on in the world of humanoid robots for someone like me who only knows that they're science fiction. I appreciate that, but I'd like you to tell me a little bit about Agility Robotics specifically. Where do you guys fit into the picture?
Yeah. So Agility makes humanoid robots or dynamically stable mobile manipulators for the logistics and
call them as they really are. Right.
For the logistics and manufacturing industry, we're working with a lot of interesting customers. We've been deployed with customers since July of last year. And today at the show, we're showing off our new V4 robot that has a lot of really cool improvements and exciting additions like automatic charge docking. And we also have a live stream. So if you search Agility Robotics ProMat, you'll be able to see the recorded live stream from our booth even after the show.
Called the V4. You don't give it a cute name, huh?
Yeah.
Cute human name that people will bond with it.
It's called Digit.
Okay. Thanks so much, Melanie. I really enjoyed talking to you.
Awesome. Thank you very much. I appreciate it.
I've been speaking with Melanie Wise of Agility Robotics. Thank you very much for watching.